Hi everyone, today we're going to be talking about Chapter 6, Part 2.
Today we're going to be learning about 6.4, which includes graphs of sine and cosine functions.
And 6.6, which is phase shifts and sinusoidal curve fittings. Okay, so now I'm going to bring you through the steps of graphing these functions. So the first one is to establish the amplitude and the period. We'll get into those steps later. And then to be able to plot your graph, you're going to need to divide your intervals and your period into 4 subintervals. So then you can use your subintervals to obtain 5 points on the graph. And then from there, you're going to plot and graph one complete cycle, and that's how you're going to get it.
The equation formula, and here is the formula to find your period. Both of these will be necessary when finding the upcoming problems.
We're going to be talking about graphing trigonometric functions. Step 1, factor out the W. Step 2, identify the period and the amplitude. Step 3, identify the phase shift, also known as the horizontal shift. And then step 4, graph, and split the graph into 4 intervals and sketch the curve using 5 key points. So in this section, we will be plotting the graphs of the sine and cosine functions separately, both in the x and y plane. We will also use x for the independent variable and y for the dependent variable.
So we are going to start by explaining and reviewing the cosine and sine graph, because you will need the basis of this in order to do the equations that we do later in the video. So the first one is a cosine graph, and to know that it's a cosine graph, you are starting at your maximum and you're also ending at your maximum, and in this case it's 1. And in a sine graph, you are starting at the midpoint, which this is just basic, so there's no vertical or phase shift, and you go up to your maximum, down to your minimum, and so forth. And for each of these can go on forever and ever, but these are just the standard basic ones. So you'll see something like this, but just more complex in later problems. Okay, first we're going to be given a graph, and we have to find the equation. So we know that this is a cosine graph because it starts at the maximum of 2 and it ends in the maximum of 2, meaning that the amplitude is 2 because that is the maximum. So first we're going to write y equals, and seeing that we know that the amplitude is 2, we're going to write 2 because the amplitude always comes first, cosine. And so now we need to find our w to put in the next part of the equation. So we're going to use our formula, period equals 2 pi over w. And we know that our period is pi because it is the last number in the one cycle. So pi equals 2 pi over w, and we need to know what number under 2 pi equals pi. And we know that 2 pi divided by 2 equals pi. So pi equals 2 pi over 2. And so our w equals 2. So now we're going to add that into our equation, and this is the answer. We're going to be doing the same thing, but it's question 2. So first we need to find if it's cosine or sine, and we know that it's cosine because our arrows are right here, and these are both ending and starting at the maximum number, which is also equivalent to the amplitude, which is 3. So again, we're going to start with y. So y equals 3 because that's our amplitude, cosine. And again, now we need to find our period. So we know that period equals 2 pi over w, and our period is 1 because this is the last number in the cycle. So 1 equals 2 pi over w, and we need to find this number to make 2 pi over a number equal 1, and we know that 2 pi over 2 pi is 1. So w equals 2 pi, and we add that into our equation right there.
Okay, next I'm going to be graphing the equation y equals -4 cosine 2x plus pi. Okay, so to start off with the equation, it is going to be y equals -4 cosine, and then I'm going to factor out this 2 to get x plus pi over 2. Next is going to be the amplitude, which is just going to be 4, positive 4. Phase shift is going to be the opposite of this number here. So negative pi over 2. And there is also no vertical shift. Okay, so to start here, I'm going to be starting with negative pi over 2, and then negative pi over 4. And then for the positive side, it's going to start with pi over 4, then pi over 2, and I'm going to add a couple more, so that would be 3 pi over 2, and then pi. And because it is a cosine graph, we're going to be starting at the maximum here. I'm going to erase that. Okay. So start here, and then you go next point, down to the minimum, back up here, and then end again at the maximum. And then connect these points to get a cosine graph. Okay, so now we're going to be doing another problem, but this one includes a vertical shift. So the question is asking us to determine the amplitude, period, and then the also domain and range of the equation y equals negative 4x, pi x minus 2. And I'm going to be graphing just one cycle. Okay, so the amplitude of this equation is going to be positive 4, and the period is going to be 2 pi divided by pi. Cross those out, so it's going to be 2. Okay, so now that we found the amplitude and period, we're going to start our graph and then find the domain and range. Okay, so to start, our new midpoint is going to be at negative 2 because we have a vertical shift of negative 2. And then we're just going to move down by 2, so negative 2, negative 4, negative 6, and here is our new midpoint. And then we're also going to do positive 2, positive 4, and then positive 6. And then for these points here, we're going to start with 1/2, and then to 1, 3 over 2, and to 2, because our period is 2, so we need to end at that point. So to start the graph, we start at our minimum, which is negative 6, and then move up to negative 2, 1/2, and then 1, 2, and then back down to 3 over 2, negative 2, and then back down here to 2, negative 6. And we're going to graph by starting our arrows here, and then moving up like that. Okay, so now that we have our graph, I'm going to be finding domain and range. So to start, the domain will be, in parentheses, negative infinity, infinity. And the range is going to be in brackets because it comes to a stopping point, which is going to be the minimum of negative 6, and then the top point, which is at positive 2.
So this is the equation that I'll be using for my open response question. Imagine you're floating on a tube in a wave pool. At t equals 1 second, you reach the maximum height of 7 feet above the bottom of the pool. At t equals 5 seconds, you reach a minimum height of 3 feet above the bottom of the pool. Assume that your height above the bottom of the pool is a sinusoidal function of time with a period of 8 seconds. So I'm going to teach you guys or refresh your minds on how to solve an open response problem. I erased the equation, the prompt, so I could save room for myself, but I have it on my phone. If I keep looking down, we'll put a picture for you guys if you need. So we're going to start off with period. Period, they put it directly in the equation at the end, and it is 8. From there, we're going to put it into our period formula, where you have 2 pi over w, w being 8. And then you're going to cross these and simplify, which just gives you pi over 4. For amplitude, you do maximum minus minimum, which is directly in the paragraph, divided by 2. So you have 7 minus 3 equals 2, which gives you 4 over 2, and your amplitude is 2. For your vertical shift, you're going to do the exact opposite, and you will have 7 plus 3 divided by 2, give you 10 over 2, which equals 5. Now to plug in, you're going to do it, and phase shift. The phase shift, again, it says at 1, it says it in the paragraph, and it says you start at 1, so that's your phase shift. You're starting at 1 instead of 0. So to start with your equation, you're going to start with amplitude as you usually would. And here, this is where you're going to put your period, hours being pi over 4. And then here is where you put your phase shift. Our phase shift, as we learned earlier, is just 1. And then at the end, you're going to have our vertical shift, which, again, they tell you directly here with the maximum plus the minimum divided by 2. That's going to be 5. And that is your equation you're going to work off of. Okay, so now time to graph. Since we have all of our information, we're going to label our y-axis, height in feet, and our x-axis in time and seconds. And because of our vertical shift, we're going to instead start at 1 instead of 0. And we're going to start at our maximum because it's a cosine graph. And we're going to start plotting our first right here. Because the amplitude is 2, we know that our middle, if you want to say, midline, is going to be at 5. So then we're going to plot right here. I'm just skipping lines. And then we're going to go another 2 down because this is our middle, so we need to subtract 2 as we added 2 up top. And that will give us right here. And then we are going to do the same, just going back up, because now that this is our vertical shift in our midline, we're not going to have to go down to the minimum. So now we go over another and up back at 5, and then another and go back up to our maximum. And this is what our graph looks like. If it makes you easier to see, this is what the vertical shift, that's off. That's what our vertical shift gives us. Phase shift, nope, vertical shift. Okay, that's good. So if your prompt asks you what the plot is at a specific time, it could be 3 seconds or 6 seconds, you can use this equation right here to figure that out. So you're going to plot in, say, for example, it's 3 seconds. You use this exact formula, and at t for time, you're going to plug in 3, and that's going to give you an exact, if you wanted to continue this graph, it's going to give you an exact plotting point. But yeah.
3, 2, 1.
Thank you for
Watching our video on 6.4 and 6.6.
I hope it was a good refresher.
You will need to know for finals, so pay attention.
These are some bloopers.
Have fun.
Today we're going to be talking about trigonometric functions. Step 3, identify the shapes.
Oh, sorry.
Okay, hello.
In
I want to do.